Okay, I'm Mohammed Ikhtiar. Okay, we are discussing a question for the constant acceleration for the horizontal motion. For this is the second question. A stone is sliding across a frozen lake in a straight line. The initial speed of the stone. So straight line in a straight line, so it's moving horizontally, obvious. The initial speed of the stone, initial speed is given 12 ms minus 1. The friction between the stone and the ice causes the stone to slow down. So friction they mentioned here. So no forward force. So obviously object going to decelerate. The constant rate is given 0.8 ms minus 2. So each and every second 0.8 meter per second speed is reducing. So initial speed is 12. So the next second the speed will be 12 minus 0.8. Then the second on the second the speed will be 12 minus 0.8 is 11.2. So 11 point minus 0.8. So every second the speed is decreasing by 0.8. So the constant rate is given. That is a we call deceleration. Then questions are the distance traveled by the stone before coming to rest. So when they mention before coming to rest, so the initial final speed will be 0. Final speed is 0 over here. Initial speed is, we know that is 12. Initial speed is 12, and the acceleration, that is decreasing, speed is decreasing by 0.8. So acceleration will be minus 0.8 ms minus 2. Then speed of the stone, the second question, the speed of the stone at the instant when it has traveled half of this distance, the second question. So there are two questions, we need to answer one by one. Distance traveled by the stone when it comes to velocity 0, that is the first question. Second question, we need to find the speed at the instant when has traveled half of the distance of the way, right? The middle, right at the middle, we need to find the speed. Okay, that is, we're going to discuss one by one. Change into diagram, it will be easier. Change into diagram. Initial speed is 12. Acceleration is given 0.8. So it's decreasing by 0.8. So we write minus 0.8 ms minus 2. And the final speed is 0. So we need to find the displacement. So just list it. Initial is 12. Acceleration is minus 0.8. Final speed is 0. When you compare this everything, right? So initial speed, so there are three quantities given. The fourth quantity is we need to find displacement. So V, U, A, S, when you go through that, automatically, right, you can use V squared is equal to U squared plus 2AS to find the displacement. So V squared is here 0, U squared will be 12 squared, plus 2 times acceleration is minus 0.8 because the speed is decreasing by 0.8 because of the friction, no forward force. If it is any forward force, then there is an acceleration. So here no forward force, just only the friction resistive force. So speed is decreasing, so we have written minus 0.8. The displacement is, we are finding the quantity, so you can find out S. 1.6 S is equal to 144. S you can calculate 144 divided by 1.6 will be, you will get 90 meter. So the total displacement by the object, right, cover, right, this object covered 90 meter. 90 meter. Now for the second question, the speed of the stone at the instant when it has traveled half of the distance. So we need to find the speed when he's traveled half of the speed. So here the speed at the midpoint is say v, and half of the distance, so 45 meter. 90 divided by 2 is 45 meter. Okay, half of the right, this acceleration is same throughout the motion. Acceleration is minus 0.8. So we can use here again the same quantities: initial speed, acceleration, and the final speed is here. Final speed is v, and the displacement is, we know, 45 meter. So we can again go through u, a, v. We need to calculate. So s, same equation. So v squared is equal to u squared plus 2as. V squared we are finding. U squared will be 12 squared, so 144. 12 squared is 144. 2 times acceleration is minus 0.8. Displacement from here to here will be 45. So v squared will be 144 minus 45 into 8, right? It's 45, 90 will be 80, 72, right? We can calculate that. Will be okay, minus 72. So you can calculate v squared will be 72. So v will be a root of 72. The final speed at the midpoint. Okay, thank you. If you feel is useful, you can share and you can comment and you can subscribe. And if you have any doubt, you can write in your comment box. Thank you.